Mars is both a wonderful and a terrible place to go looking for life. For the first billion or so years of its 4.5 billion year lifespan, it was awash in oceans and seas and protected by a thick blanket of air. Eventually, however, its magnetic field shut down, allowing the solar wind to claw away the atmosphere and the water to vanish into space. Now, scientists have found a new evidence of an ancient freshwater lake on Mars well suited to support microbial life in the Gale crater. But is it really what we think it is? Let's find out. Welcome to Space World. In today's video, we are going to talk about the evidence of ancient lake in the Gale crater. So if you want to know more about it, then stay with us until the end of the video. NASA's Curiosity rover touched down inside the 96-mile-wide Gale in August 2012 on a mission to assess the area's past life-supporting potential. NASA intentionally landed the rover a few miles away from a huge depression called Gale Crater. It was chosen as Curiosity's primary destination because of a giant 18,000-foot mountain at its center, nicknamed Mount Sharp, that appeared to be made out of sedimentary rock layers. On Earth, sedimentary rocks usually form as a result of water movement. So, at a spot near its Mars landing site called Yellowknife Bay, the car-sized robot found fine-grained mudstone sediments, strong evidence of an ancient lake. Later on, as it roamed the crater over the ensuing months and years, Curiosity spotted more and more signs of past liquid water, leading the rover team to conclude that Gale hosted a big lake about 3.7 billion years ago. Now, after a decade on Mars, scientists think they now understood how Mount Sharp formed. They believe that Gale Crater was once a lake and that rivers once flowed into the lake, carrying bits of sediment and depositing them in layers, gradually forming rock. Just as sedimentary rocks typically form on Earth, over time the lake appears to have repeatedly filled, then evaporated away, then filled again, depositing new layers of sand and silt each time. Later on, wind erosion seems to have helped carve out the rock layers. Eventually, this revealed the original lake bed, with an exposed rock structure at its center, Mount Sharp. This lake was large enough it could have lasted millions of years, sufficient time for life to get started and thrive, sufficient time for lake sediments to build up and form Mount Sharp. Michael Meyer, Mars Exploration Program lead scientist at NASA headquarters in Washington, said during a press conference. A new study, however, offers a different interpretation of Curiosity's data and Gale's past. While the Yellowknife Bay mudstones likely were deposited in an ancient lake, the majority of the stratigraphic section corresponds to sandstone and interbedded mudstone sandstone, which are intensely weathered but likely not lacustrine in origin, based on the suite of sedimentary structures, mineralogy, and geochemical trends observed as a geological formation, researchers led by Hong Kong University, HKU doctoral student Jiacheng Liu wrote in the paper, which was published in the journal Science Advances. Liquid water caused that weathering, but it didn't occur in a lake, Liu and his colleagues suggest. They propose a different scenario. Most of the deposits examined by Curiosity came into the center via wind and/or volcanic activity, then were altered by acidic rain. This is probably precipitation-driven chemical weathering of a soil-type environment, study co-author Joe Michalski, deputy director of the HKU's Laboratory for Space Research and Liu's doctoral advisor, stated. So the data gathered by Curiosity, which is still going strong today, point to the existence of a handful of small lakes in Gale long ago rather than a single big one, Michalski said. Those little lakes were probably relatively transient, persisting for a maximum of a few tens of thousands of years at a time, he added. Therefore, if Liu, Michalski, and fellow HKU co-author Mei-Fu Zhu, none of whom are members of the Curiosity mission team, are right, then it may have been tougher for life to get going at Gale than scientists had thought. The larger and longer lasting that a life-conducive environment is, after all, the better the chance that chemistry will produce something complex and interesting there. There are other consequences of this interpretation as well. For example, it pegs Gale crater as less of an outlier than generally believed, and therefore more representative of ancient Mars as a whole. And that's an exciting prospect, Mikulski said. That means that we understand the environmental conditions in a broader sense by looking at something that's much more average, he said. Now, why is a lake on Mars a big deal? Curiosity has previously found evidence that Mars was once home to liquid water. Soon after its 2012 landing, for instance, it found rounded rocks that appear to have resulted from erosion due to flowing water. But Mars isn't warm enough for liquid water to exist today. All its surface water appears to be locked in its polar ice caps. For scientists, this has created a mystery. Why would Mars have been warmer long ago? Some speculate that ancient volcanic activity and a thicker atmosphere could have warmed the planet up, but only for very brief periods of time, perhaps as short as a few years. This could explain the evidence of ancient streams, but also make it seem very unlikely that Mars could have ever evolved life. Therefore, the new evidence of a lake is a big deal because it upends this theory. The lake bed and other evidence collected by Curiosity indicate that Mars was warm enough for liquid water for a much longer period, perhaps millions or tens of millions of years. Furthermore, NASA climate models suggest that in order to maintain water flow, Mars likely had a large ocean in its northern hemisphere, the sort of giant body of standing water that seems most likely to allow life to evolve. So, does the lake mean that there was once life on Mars? Not necessarily. If the lake finding is correct, it means that Mars was once sufficiently warm to evolve life as we know it. But that's not the only condition necessary for life. On Earth, at least, all organisms are made up of organic compounds, carbon atoms bonded with other elements that serve as the basic building blocks of life. And it's not yet certain that these compounds exist on Mars. In 2012, Curiosity did report finding some simple organic compounds, but it was unclear if they actually originated on Mars or had been carried there on the rover itself. NASA is holding another press conference to discuss new information about organics on Mars, but one researcher involved has stated that the 2012 finding has essentially stayed the same. They believe there's a good chance the organics are actually Martian, but they still don't know for sure. Additionally, even if you had liquid water, organic compounds, and enough energy and time, it's still far from certain that life would evolve. It took roughly 1 billion years for life to evolve on Earth, and for all we know, that may have been a singular accident, an exceedingly unlikely event that happened to occur against all odds. Or it could be a predictable event that happens whenever conditions are right. So at the moment, we just don't know. When studying the evolution of life, our sample size is 1. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.